Hey, hello everyone. Today we're going to be looking at how to solve equations on equations with variables on both sides. So a common theme in this is going to be our previous knowledge on each of our algebraic operations and their respective inverses. So we'll need to know our operations, and we'll need to know our inverse operations. This was true from when we saw one-step equations, but we'll also need a bit of a new knowledge or application of older knowledge, and that's going to be on combining like terms. This is going to be the biggest theme in this section here. Combining like terms. We'll see what I mean once I start getting into these examples. This lesson is one that warrants itself a bit more to using examples rather than focusing on terminology and vocabulary. We'll just need to recall our knowledge of combining like terms, making note of things like our coefficients, what each variable is, and what their exponents are. We're not going to be doing any operations with the exponents. We just need to know which variables have which exponents. So if we need to combine like terms using that criteria, we can. So let's look at a couple examples. I'll just be taking these directly from the lesson on solving equations with variables on both sides. Once this loads. Okay. So we'll start with this one right here. 14x minus 9 equals 7x plus 12. So there are strategies we need to take or should follow when solving these. The first is we want to choose the side for our variable, or more accurately, for our variable term. So what this is saying is, because we have two variable terms here, we can clearly see that with 14x and 7x, we need to decide which side of the equation our variable should end up on. The common strategy for this is to choose the larger variable term, that is to say the variable term with the largest coefficient, simply because it has a higher probability of keeping us from having to deal too much with negative numbers. It wouldn't affect our overall solution, but it does make the process a bit simpler and a bit less reliant on calculations and more reliant on the concept itself. So looking at our two terms, 14x and 7x, I can see that 14 is certainly a larger number than 7. So 14x would be the larger variable term. It means I should take this 7x and move it to the other side of the equation. Now, we have to keep in mind that we can't just move something to a side of the equation. We have to use our algebra terms to move an entire term. We know that every term, by definition, is separated by addition or subtraction. So we will need to use a form of an inverse operation here, knowing that we have a set positive term. The way I would effectively remove it from one side of the equation would be to subtract it. If this was a negative term, I would have to move it by setting this up as an addition. So I'm going to take this 7x and I'm going to subtract it from both sides of the equation. I always line up my variable terms with my variable terms because it keeps the next step of actually combining like terms much simpler, much more organized. 7x minus 7x will go to 0x, which is just 0. We never would write 0x. So this term will effectively cancel out. That brings us into our second step on the left side of the equation, which is to combine like terms. Just looking at on the left side of the equation, 14x minus 7x. Again, whenever we combine like terms, we really just need to deal with the coefficients, counting how many of this variable do we have. 14x minus 7x is 7x. So the rest of the equation is still written down. I have a positive 12 here because it's being added. I'm just going to write 12. There's no need to write positive 12. I would only need to write a symbol there if it was negative, in which case I would write negative 12. But if it's positive, I'll just write 12. This brings us to our third step, which is to move the constants to the other side. Move constants. So very similar to what happened before. I know I have two constant terms. I have a negative 9 here and a 12 here. I need to move the negative 9 to the other side of the equation. I can't just move it though. I have to use an algebra operation. So this negative 9 or minus 9 in terms of this expression on the left here needs an inverse operation to happen, which will be addition. So I add 9 to both sides of the equal sign. Negative 9 plus 9 will go to 0, canceling these two terms out. This will leave 7x on the left side of the equation, and 12 plus 9 gives me 21 for the right. Write a better 2 than that. And this brings us to the final step. Solving these is solve the actual equation. Now this is a one-step equation that we've done before. I have 7 times x equals 21. The inverse operation of multiplication is division. So I will divide each side of the equation by 7, leaving me with a final solution of x equals 3. So there are more steps into solving these types of equations, but it is mostly revolving around combining like terms. As long as you're okay with combining like terms and you're confident in your algebraic operations, this should present no real issue. We're going to look at one more example. Let me choose one because sometimes we will be faced with a more involved problem where we have to make use of another piece of knowledge. So if I have this equation, 15x plus 7 equals x plus 3, then in parentheses, x minus 5. We'll need to recall our previous steps that we've taken, but notice we have something else here. Notice we have a set of parentheses where we previously did not. Now, the way we deal with these parentheses depends on what's inside the parentheses and what's around it. In this case, x minus 5 cannot be simplified because they're not like terms, but I do have a constant in front of the parentheses which signals that I need to use the distributive property. This is something from way back in a previous lesson, but it shows up often. Whenever you see parentheses, know that you'll have to look to simplify them to remove the parentheses before you can really fully solve your equation. But the rest of the equation I'm going to write down as usual. 15x plus 7 equals x, and I'm going to actually distribute. 3 times x is just 3x, and 3 times negative 5 is negative 15. So all I've done here so far is distribute. My next step is going to be my first actual combining like terms, but it's actually going to be on the same side of the equation, x plus 3x. So the rest of it, I'm still just writing down what I had. Haven't changed anything over here. Over here, I have x plus 3x, which is 4x. And the minus 15 was already there before, so I just need to rewrite it down. Now, this looks like the previous problem. We just had the extra added step of distributing and combining like terms before we could actually get to what the previous problem looked like. Now I can actually decide which side the variable terms are going to go on and actually start performing my inverse operations. My two variable terms are 15x and 4x, noted right here. 15x is the larger variable term, so I'm going to move the 4x to the left side of the equation. This is where I need to remember my equal sign is like a mirror, and I need to actually do the inverse operation here. To move the 4x, I'm going to subtract 4x from both sides. I'm going to line up my like terms. 4x minus 4x will cancel. 15x minus 4x will give me 11x. The rest of the equation I will copy down as it already was. Here I have a negative 15. It was minus 15, so I want to include that negativity. And from here, I just proceed as usual. Now I have my variable terms on one side. I need to move my constant terms. My constants are a positive 7 and a negative 15. So to move my positive 7, the inverse operation of plus 7 will be to subtract. 7 minus 7 will cancel. This will leave me with 11x on the left-hand side. And negative 15 minus 7 is negative 22 on the right-hand side. Now for the last part of the equation, I ran a little bit out of room, so I'm going to rewrite it up here. The last part of the equation, I just need to finish solving. So my final step in solving this equation is going to be dividing by the coefficient on both sides of the equation. This will cancel out the coefficients on the left of 11, leaving just x, and on the right-hand side, negative 22 divided by 11 is negative 2. So again, these are a bit more involved now. We just have to keep in mind our strategies of first simplifying each side of each expression as much as possible, then deciding which side of the equation we want our variable terms to go to, ideally picking the larger term to determine that side, then combining our like terms, then move our constants to the opposite side, combining those like terms, and finally solving our equation. The final step of solving the equation is almost always done by dividing by the coefficient. Hopefully this video has been helpful in solving equations with variables on both sides. Our next lesson will involve a bit more complex equations. Thank you.